Hello, welcome to the portion of the tutorial where we're going to be using the simple game engine to create a puzzle game. Now, I've already done some of the initial work for this in that I have added the simple game engine.m and a PNG to my file path, and I've done some pseudocode work so that creating the code will be a little bit simpler. The basic idea is that this is a tile shifting game. It'll randomize the position of 24 tiles on a 5x5 grid to leave one open space for the player to shift to adjacent tiles. So this will be shifting these tiles for this OSU logo puzzle here. Players are going to choose which tile to shift by clicking. So you'll click on a tile next to the open space, and that will shift that tile into the open space, moving the open space as well. We're going to have it be that you have to left click so that right clicking will undo your last move. And then the game will continue to go until you've gotten the puzzle back to this state after it's been randomized. So that's the idea behind what we're going to do. So let's jump into how we're doing it. Okay, so the first thing we need to do is define a simple game engine object. You always need a scene, so let's just call it puzz scene. And that's going to go in by saying equals simple game engine. And the arguments that takes is open quotes OSU underscore puzzle, that being the name of the PNG with the .png as part of it. And you need the size. This is a 16 pixel image. Let's do zoom factor of 5. That's a good size. And we don't necessarily have to do the RGB values, but it defaults to a black background, and I think the white looks a little bit better for what we're doing. So we're going to add 255, 255, 255 to get that white background. All right, the next thing we need to do is initialize some variables, specifically for the solved puzzle. So let's start that up. Solved equals, and so what we want here is just a 5x5 matrix with the sprites arranged as they should. So since sprites come standardized to 1 through 5 on the first one, 6 through 10 on the second line, and so on, we just want to have that be what our standard matrix is, because this is how simple game engine reads sprites in that order, left to right, top to bottom. So once we've got all of those in place, we have the matrix for our solved puzzle. Now, to randomize it, we need some sort of randomizer. So a good way to do randomizer is to use the randperm function. Now, what this does is it gives you an array with a random ordering of the numbers from 1 to whatever number you put in it. So with 25, that's going to randomly order the numbers 1 through 25. This is a good way to shuffle a deck, or in any way randomly order a known quantity of items. Now, the way you use this, so we're going to set the puzzle. This has to be another 5x5 matrix. The way you use the randomizer is that you use that randomly ordered set of things as indexes for whatever else you want to be doing. So randomizer 1 through 5. And so what that does is it takes the first 5 items in randomizer, which will be a random subset of the numbers 1 through 25, and that'll be the top row. And basically we're going to do that for every single row here. We're going to be doing the same creation method as above, but using the randomizer indexes instead of just the numbers. So this will put the first 5 numbers of the randomizer for the top row, the second 5 numbers for the second row, the third 5 numbers, and so on. And we're getting a little bit too long here, so we're going to use an ellipses to make it on the second row to keep it clean. And randomizer 21 through 25. And that is how we are going to create our randomized puzzle. So this should now have all the numbers 1 through 25 in a random order set up in a 5x5 grid. And this we don't need. Great. So we've got our randomized puzzle, a randomizer, and our solve puzzle. So a few other things we're going to need to track as we do a game like this is we're going to need to keep track of where the open space is, because if we're going to need to be able to know where that is, we need to track it. So we have just randomized where the open space is. It should be wherever in the puzzle the number 1 appears. And so while we could do some sort of for loop to figure that out, I went ahead and looked up in search documentation for a function that does find. And I found that if you use it like this, this will give you the location of every place where the number 1 shows up in the array puzzle as a kind of single number index. Given that there's only 1, that just returns a single number. And now we have the location. If ever there's anything you don't know how to do in MATLAB, either using Google or the search documentation can be an excellent way to figure it out. So location clicked by user set to the same as open space. We're going to need to know where they're clicking. So we'll call it clicked. Let's just call it click. And just set that to the same as open space. And we're also going to need to track the undo space as well. So let's just call it undo C for undo click and set that to open space as well. Now we have most to all of the variables we should need. So let's see what we wanted to do next. So the next thing we want to do is we want to jump into the game and show the user what it is that's going on. So we want to show the completed puzzle for a second or two, and then switch it to the randomized puzzle. So this is where we're going to jump in with draw scene. As a quick reminder to myself, you want the scene name. So that is Puz SCN, P-U-Z, SCN, and the matrix that we're going to be using. So we want to do the solved one first. So solved. And that should display that. Now we want to wait for a bit, which we do with pause and a second or two. Let's split the difference 1.5 before doing draw scene, Puz scene, puzzle, and show the randomized version. So this should just update the figure and give the new randomized one that we can begin playing with. And since that's where we begin, we can begin our main game loop. So our main game loop should be a while loop because we don't know how long it's going to go for. We just want to go until the time when the two puzzles are the same. So we're going to have solved and puzzle, and we're going to check when they are equal. Is equal is a good way to do this because if you just did equals equals or tilde equals to see if they're the same, that would do a piecewise thing. And then if any of them was the same or if any of them was different, it would trigger. So we want to say, so long as they are not entirely the same, so is equal, we'll give a 1 if they are entirely the same and a 0 at any other situations. As long as they are not the same, we are in our while loop. Give ourselves some space. Here's where we say end the main game loop. So we're going to come down here and hit end. Good syntax. It's always good to close your loops right when you make them. And then we're in the game. So the first thing we want to do is get the user input. So for this, we're using the mouse. So get mouse input. Now that has outputs of a row, a column, and a button. So we can just call that RCB equals get mouse input. And it takes the scene object, which again is Puz scene. All right, so that should store both the row that we've clicked on, which is how far down it is, the column, how far left to right it is, and the button, which button we used for clicking. So the left click will move, anything else will undo. So if we're checking to see whether it was a left click, then we can say if B equals 1, because that's what it is for left clicking. And we're going to need to do that. So let's, I think that should end down here. So that's if we are left clicking. So we check to see whether the cell is next to an open space. To do this, we're going to need to calculate the clicked cell location. Now this is where things get a little bit tricky because while sprites and the simple game engine sprite mapping engine count from left to right and then top down, MATLAB itself gives single number indices for things in matrices, top to bottom, left to right. So whereas we're clicking and we're getting a row column array of 1, 1, that'd be the first one, but then MATLAB will count down. So we just got to keep that in mind as we're going. So this is one of the things you're going to need to think about a little bit as you're using simple game engine is how are the number systems I'm using working? And that's all we need to do. So calculate this cell's click location. Now that's stored as RC. So we want to update clicked, just call it click. Click equals, and that will be, let's see, so we want 1 for here, so that, and 2 for here. So we want the row plus some multiple of the column minus 1. So now we're getting to 4 and the column's 2. So that should be plus 3 for this one. So no, this is a 5 by 5. So we've got 5 for every row. So this will be 5 times that. Okay. So 1, 2, 3, 4, 5. So on the first column, 6, 7, 8. Yeah, this is what we want for clicked. The row, so how far down we are, plus 5 times the column minus 1. So that's how far down we are plus 0, how far down we are plus 5. So that at the end, we should be getting to 25 because that'll be 5 rows down and 5 times 4 is over. There we go. That's how we've done that calculation. So that was one of the trickiest parts that we need to do is just figuring out what this bit of math was. Okay, so once we've got that out of the way, now we can determine how we are interacting with the rest of the thing by comparing that location to the open space. So we got if click equals, and then we're comparing it. So we want 1 or more or less than open space. So open space minus 1. So that will be if the click is 1 space off from that, or 1 space in the other direction, plus, and got or, now we need to be, so that was 1 row off. Now we need to do 1 column off, which means it would be separated by 5. So that's a 5 and that's a 5. So this should be if click is off by just 1 row, 1 row below open space, if click is 1 row above open space, if was 1 column above or 1 column below. So again, this comes by comparing the click to the open space. Then we know that we're clicking one of those 4 things, and so we can move on to what we want to do. So if the click spell is next to the open space, then we want to swap the sprites between the 2 tiles, which means that we want to take puzzle at open space and set it to whatever we had in puzzle at clicked, which is, again, still just click. And then we want to do puzzle at click. We want to set that to the open space tile, but we know that that's 1, so we'll just say that 1. And then they're swapped, simple as that. So now we need to store the old space location in undo so that we know where to restore to. So undo gets open space. And we do that before updating the location of open space to where it is now, which is wherever we clicked. Excellent. And that's all we need to do to swap the tiles around. Check whether we're in the right position, swap some things around, and update where we are going to. So if it's not the left click, so then we need an else statement. We want to undo by swapping the previously clicked cell and the open spaces, which is to say we're swapping the sprites. So the puzzle at undo open space becomes the puzzle at undo, and then the puzzle at undo is going to go to 1. So again, just kind of swapping back where it had been before. And that's all we wanted to do under those circumstances. We don't need to update any of the positions. No, we do. Space needs to go to undo because it has moved. Okay, great. So we've updated that index, we've swapped the things, and it won't undo more than once the way we've got it set here, and that's fine. So we're out of our if statement. So let's indent that appropriately. Out of our if statement. And we've messed up a little bit because currently this else is attached to that. So we need to add an extra end statement there. And then these can come here. So if not, a left click. There we go. All right. So now we are outside of this. And regardless of what happened, we should be done updating. So now we can show the updated puzzle, which means we need to draw scene again. And we need the puzz scene, and we need the puzzle. And that should show us where we are. And at that point, we're done with the main game loop. It is good form to show that the game is over. So to do something like that, you could just use something like the title function or an fprintf, depending on where you want to announce it, but that's really up to you. Right now, we're just going to go ahead and see if our game runs. So, oh, great. We do have an error, so let's take a quick moment to debug. It's on line 18. And what did we do wrong? 42. Barely use parentheses. Oops. Right then. There we go. There's our main puzzle. It's solved, and we have randomized it. So now we click there, and we called it puzzle on line 84. You need to make sure your caps lock isn't on. You don't capitalize things that should not be capitalized. Third time's a charm. There's our solved puzzle. There's our randomized puzzle. And now we can click around next to it, and things move. And if we right click over here, it'll go back. Great. And that appears to be working just fine. I'm not going to try to solve the whole puzzle because that would take a very long time indeed. But we have a working game, and it's only been 15 minutes or so. So thanks for watching. Hopefully this has been insightful and can help you with your own simple game engine game. If you need any help, of course, you can ask the GTAs or UTAs for assistance or your instructor. Anyway, good luck with your simple game engine works. Bye, everybody.